Alright, we're going to look at area of similar figures. Make sure you're looking at the purple page that says area and not perimeter. For these, we're going to find what the relationship is between the area of a figure and the scale factor when it is dilated. When we have area of similar figures, if we have polygon ABCD and polygon LMNP, these are dilations. They are different sizes. If two polygons are similar, then their areas are proportional to the square of the scale factor between them. Another way to say this is that if we have the area of ABCD and the area of LMNP, it is equal to their scale factor squared. Under the tab that says Finding the Area Ratio, we're going to look at our two pentagons. We have a larger pentagon that we're going to label A, and the smaller pentagon we're going to label B, so we're having a figure that shrinks. The ratio of the areas, if we have side B to side A, our scale factor is 8/10, which is equal to 4/5. 8/10 is equal to 4/5. The area ratio, or the ratio of the two areas for our figures, would be our scale factor squared. So we're going to take 4/5 and square that. When you square something, it means to multiply by itself. So 4/5 times 4/5 would give you 16/25. So the area ratio is 16/25. It's your scale factor squared. The area of the smaller pentagon is 16/25, the area of the larger pentagon. Looking at our rectangle to the right, we have rectangle A that is 5 units in length and rectangle B that is 15 units in length. So our ratio of side B to side A is 15/5. That means this shape got larger. Our ratio, 15/5, is equal to 3/1, or 3. The area ratio is equal to your scale factor squared. So our scale factor in this problem is 15/5. If we square the scale factor, 3 squared is equal to 9. So there would be 9 smaller rectangles that fit into our larger rectangle. The area ratio is 9. I know this picture doesn't look like 9 of them will fit, but remember on this picture, they're not to scale. We're just told that they're similar. So 9 smaller rectangles would fit into the larger one. Under the next tab that says Finding the Area, if we are given two similar shapes and we know the area of one of the shapes, here we have the area of the smaller shape, so this should say that we want to find the area of the larger shape. The area of our smaller shape is 10 square inches. It has a side length of 4. We're going to look for the area of our larger shape. Our scale factor is the ratio of our two sides. We're going to have our scale factor from our image over original. So our scale factor is 12/4, which is equal to 3. That means our area ratio is our scale factor squared. Remember, to find area, you have to square that scale factor. 3 squared is 9. If you think about finding area, when we find the area, it's in units squared, so that is one of the reasons why we square our scale factor. Our larger area to our smaller area has to be equal to 9, or 9/1. When we set up our proportion, our larger area is going to be 9 times the area of the smaller figure. So our area for our small one is 10 units, 10 inches squared. In our proportion, our smaller number is in the denominator, so our 10 for our smaller area is going to go in the denominator. 1 times 10 is 10. To find our missing area for the larger one, we're going to multiply the top of this by 10. So 9 times 10 gives us an area of 90 square inches. Under the tab where we are finding the scale factor, if we have the area of two figures and they want to know what scale factor was used to shrink or enlarge this, we can use our knowledge that the area is the scale factor squared. So our area for figure B in our triangle, this figure has an area of 16 units, and the area of triangle A has an area of 25 units. Remember that the opposite of squaring something is to square root it. So we can find the square root of 16 25ths. We want to know what number times itself would equal 16 over 25. Well, the number times itself that is equal to 16, or the square root of 16, is 4. The square root of 25, well, 5 times 5 is 25, so the square root of 25 is 5. That means the scale factor that was used to change the shape was 4/5. We know that we needed a number smaller than 1 because our triangle A shrank to make triangle B, so our scale factor has to be smaller than 1. In this problem, it is 4/5. The next two, the trapezoid A and trapezoid B, we have area of trapezoid A is 15 meters squared. Area of trapezoid B is 60 meters squared. To find the scale factor, this time our shape was enlarged, so we know our scale factor has to be greater than 1. On the top of our ratio, the area for figure B was 60 meters squared. The area for figure A was 15 meters squared, so 60 over 15 is going to reduce to 4 over 1. That is the ratio of our areas. To find the scale factor, we need to square root this. The opposite of squaring, this was scale factor squared, is to square root. 4 over 1 is 4, so the square root of 4 is 2, or 2 over 1. Our scale factor is equal to 2. This shape got twice as large in the ratio of the lengths of the side. And on the very last one, if we want to find the missing side for a figure, these two shapes are similar. We want to find the missing side. This should say of the larger shape. We know the missing side of the smaller one. So we have a polygon that has an area of 75 square meters. That's polygon A. Polygon B has a area of 3 square meters. The area ratio, our smaller figure, the image, has an area of 3. The larger figure has an area of 75. 3 over 75 can reduce to 1 over 25. Now, to find the scale factor, we have to square root this because our area is scale factor squared. So the opposite, if we know the ratio of the areas, we have to square root the square root of 1 over 25. The square root of 1 is 1 in our numerator. 1 times 1 is 1. The square root of 25 is 5. So our scale factor that shrank this picture, this polygon, was 1/5. That made our picture get smaller. If we know that our scale factor is 1/5, we can use that to find our missing side for our larger figure. We know that our smaller figure has a side length of 5. In our ratio, our smaller number is in the numerator, so our 5 is going to go in the numerator because the value for x has to be greater than that. In this proportion, 1 times 5 is 5 in our numerator. In the denominator, 5 times 5 gives us a value of 25, so the side of the larger polygon would be 25 meters. Make sure you jot down any questions that you may have. You've just completed your last video for the first semester. You will not have any more videos before Christmas break. There will be some more after Christmas break, but you are done until after Christmas watching videos.